Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Happy Ramadan and have a blessed Ramadan. Lecture for Grade 8 Chemistry, Chapter number 1 Exercise, Lecture number 9, and here is Mrs. Saira Jamal. Today we will do the question number 6 of exercise. Question number 6 is calculate the number of moles of each substance in samples with the following masses. We have to find out the number of moles. What are given to us? Grams or masses are given to us, and we have to find out the number of moles. Formula of number of moles, I told you, number of moles is equal to mass in grams over molar mass. Okay, very simple formula. Number of moles is equal to mass in grams over molar mass. So let's come towards the first part. First part, the mass given is 2.4 grams of helium. So mass of helium given 2.4 grams, and according to the formula we need molar mass. So molar mass of helium, check from periodic table, is 4 grams, and in paper it will be given, so no need to learn it because it will be given in paper. Number of moles we have to find out. So number of moles is equal to mass in grams over molar mass. Mass in grams are 2.4 grams. Molar mass of helium is 4. So answer is 0.6 moles. Okay, this is part A. Part B, there is a little bit difference. That is, the mass mentioned is in milligrams. 250 milligrams of carbon. So first we have to convert the milligrams into carbon into grams, because formula is mass in grams. So we have to convert the milligrams into grams. How can we convert milligrams into grams? Dividing by 1000. So 250 by 1000 will give us 0.25 grams. Molar mass of carbon is 12 grams. Number of moles we have to find out. So number of moles is equal to mass in grams over molar mass. Number of moles is equal to, now the in grams, the mass in grams is 0.25. Molar mass of carbon is 12. Answer is 0.021 moles. Part C, 15 grams of sodium chloride. Common salt or table salt is called sodium chloride. So mass of sodium chloride is given is 15 grams. Molar mass of sodium chloride is 23 for sodium, 35.5 for chlorine. So after adding, 58.5 grams. Mass in grams over molar mass, by putting the values you can get the answer. Part D, 40 grams of sulfur. Mass given is 40 gram. Molar mass of sulfur is 32 gram. Number of moles, the same formula. So 40 over 32 is equal to 1.25 moles. Part E is again a little bit different because the mass given is in kilograms. So first we have to convert the kilograms into grams. How can we convert it? By multiplying it with 1000. So 1.5 into 1000 will give us 1500 grams. Molar mass of magnesium oxide, magnesium is 24 plus oxygen is 16. Answer is 40 grams. Number of moles we have to find out. So number of moles is equal to mass in grams over molar mass. 1500 over 40 will give us 37.5 moles. Question number 7. Calculate the mass in grams of each of the following samples. We have to find out grams. In the previous case, we found the moles. Mass was given, and in this case we have to find out moles, and sorry, we have to find out masses, and moles are given. You can see 1.2 moles potassium, 75 moles of hydrogen, 0.25 moles of steam. So moles are given. Okay, so formula of mass I told you is mass in gram is equal to number of moles into molar mass. So from the same formula you have to take out the mass. When you take out mass, so these two terms will multiply. Number of moles multiply molar mass. You can see in this formula, mass in gram is equal to number of moles into molar mass. Just you have to multiply the mass, given mass, with molar mass. Now let us see the first part, 1.2 moles of potassium. Number of moles of potassium given are 1.2 moles. Molar mass of potassium is 39 gram. Again, molar mass you will see from the periodic table. Mass in grams we have to find out. Formula is mass in gram equal to number of moles into molar mass. Given moles are 1.2. 39 is the molar mass of potassium. Answer is 46.8 grams. B part, 75 moles of hydrogen. So number of moles of hydrogen given are 75 moles. Molar mass of hydrogen, H2, you can see H2. So we will multiply the one atomic mass of hydrogen by 2, which will give us 2 grams. Mass in gram, we have to find out. Moles are 75. Molar mass of hydrogen is 2. So after multiplication, when 50 grams is the answer. C part, 0.25 moles of steam. Steam is, water vapors. Water vapors are called steam. So in steam, we will write the formula of water, H2O, and definitely we will use the molar mass of water. 2 hydrogen, an atomic mass of 1 hydrogen is 1 plus 16 because there is only 1 oxygen. So 16 is the atomic mass of oxygen. By adding these two, we will get 18 grams. So molar mass of water is 18 grams. Number of moles are 0.25 and 18 is the molar mass. Answer is 4.5 grams. Part D, 1.05 moles of copper sulfate pentahydrate. If you remember, I told you how to find out the molar mass of copper sulfate pentahydrate in my previous lecture when we were doing the MCQs. So one of the MCQ was there that the molar mass of copper sulfate pentahydrate. This is just simple, but the only difference is you have to find out the molar mass of water along with copper sulfate, because this is a complete one molecule. Okay, one molecule, copper, sulfur, oxygen, hydrogen, and oxygen. You have to count all, and while finding out the molar mass of copper sulfate, we have to also add the molar mass of 5 water molecules. If one water molecule is 18, so it's understood we have to multiply 18 by 5, because this 5 means 5 water molecules are present in the crystal structure of copper sulfate. Number of moles of copper sulfate pentahydrate, moles are given 1.05 moles. Molar mass of copper sulfate, copper is 63.5, sulfur is 32. There are 4 oxygen atoms, so 4 multiply 1 oxygen atomic mass is 16 plus 5, because there are 5 molecules, and inside there are 2 hydrogen, and 1 hydrogen is atomic mass is 1, atomic mass of oxygen is 16. These after addition will give 18, and if you multiply 18 by 5, so it will give us the answer 90. After adding all these terms and these 90, the answer is 249.5 grams. Okay, this is a little bit hard in this numerical, not hard, you need practice. So mass in gram you have to find out. Number of moles are 1.05. Molar mass we just calculated it out there, 249.5. The answer is 261.96 grams. E part, 0.15 moles of sulfuric acid. So a number of moles given are 0.15 moles. Molar mass of sulfuric acid is 98 grams. Mass in gram we have to find out. Formula is number of moles into molar mass. So 0.15 into 98 is 14.7 grams. Question number 8. This is now different. We will use different formula in this case, because we have to find out the number of molecules. Moles are given, but we have to find out the number of molecules. The formula for number of molecules is very easy, and there is no need to find out the number of moles in this. Most of students, they confused while doing these numericals, and they are searching for the molar masses. But for these type of numericals where number of molecules you have to find out and moles are given, there is no need of the molar mass, because just see the formula. Formula is very simple. Number of molecules is equal to number of moles into Avogadro's number. You just need number of moles which are given. And Avogadro number, I told you this is the value of Avogadro number, 6.022 into 10 power 23. Very simple value, you have to just learn this value. And then just put these values in the formula, you will get the answer. There is no need of molar masses or any other thing in this case, okay? Read the question carefully, then remind the formula in your mind, and then think what are the requirements of that formula. Just if all the things are available or they are given, just put it into the formula, okay? So number of molecules are equal to number of moles. Number of moles are given 2.5 moles. Avogadro's number, I told you we have to learn it. Number of molecules we have to find out. Formula by putting the values. Number of moles are 2.5. Avogadro number after multiplication will give us the answer 15.055 into 10 power 23, or by shifting the decimal you can write 1.505 into 10 power 24 molecules. B part, 3.4 moles of ammonia, the same thing, moles are 3.4, the same formula, 3.4 into Avogadro number, 20.5 into 1023, or by shifting the decimal, 2.05 into 10 power 24 molecules. The same C part, 1.09 moles, 1.09 into Avogadro's number, 6.56 into 10 power 23 molecules. Last part, 0.01 moles of acetic acid. So again, the same thing. Number of molecules, 0.01 into Avogadro's number, 0.062 into 10 power 23, or 6.02 into 10 power 21 molecules. Question number 9, it is now decide whether or not each of the following is an example of empirical formula. You have to find out that is this formula empirical or not. Check the first one. Al2Cl6, 2 aluminium and 6 chlorine. What do you think? Can we simplify these two values? Yes, of course, 2 and 6. So 2 ones are 2 and 2 threes are 6. 1:3. 1:3. So if we write the empirical formula, that will be AlCl3. That is the simplest ratio. So it means this formula is not empirical formula, because 2 and 6 is not the simplest whole number ratio. Therefore, Al2Cl6 is not empirical formula. It is a molecular formula. Got it? B part, this is Hg2Cl2. 2, 2, we can simplify it, 1, 1, HgCl. So again, this is not empirical formula because 2:2 is not the simplest whole number ratio. Therefore, Hg2Cl2 is not empirical formula. Hence, Hg2Cl2 is a molecular formula. NaCl ratio is 1:1. It is already in its simplified form. We cannot simplify it further. So yes, NaCl is the empirical formula of sodium chloride. C2H6O, can you simplify it? No, because oxygen is already in the simplified form 1, and we cannot simplify it further. So 261 is the simplest whole number ratio. Therefore, C2H6O is the empirical formula. Question number 10, TNT, PNT. Trinitrotoluene. Trinitrotoluene is an explosive compound used in bombs. It contains 7 carbon, 6 hydrogens, 5 nitrogens, and 6 oxygen. You have to write its empirical form in its simplest form. There are 7 carbon, 6 hydrogen, 5 nitrogen, and 6 oxygen. So can you simplify it? No, because they are even and odd numbers, so we cannot simplify it further. So this is the empirical formula as well as the molecular formula. So same for TNT, molecular formula and the empirical formulas are same. Question number 11. A molecule contains 4 phosphorus atoms and 10 oxygen. 4 phosphorus, 4p and 10 oxygens. You have to write the empirical formula and also find out the molar mass. First write the empirical formula so we can simplify it. 2 to the 4 and 2 5s are 10. So 2 and 5. This is the empirical formula and find out the molar mass. 4 atoms are there and atomic mass of phosphorus is 31 plus 10 atoms of oxygen and atomic mass of oxygen is 16. So answer is 284 grams. Indigo, the dye. It is a dye used to color blue jeans and it is a compound and known as indoxyl. And we have to find out the molar mass of these compounds. Also write there empirical formulas. There are two compounds. One is indigo and one is indoxyl. And you have to find out the empirical formula for the first one. And also they say find out their molar mass. First, we will find out the molar mass of indigo 16 into 12, 1 into 10, and 2 into 14, and 2 into 16. 192 plus 10 plus 28 give 262 grams is the molar mass of indigo. And empirical formula of indigo is 1610O2. Yeah, we can simplify it. So on 2, it will give us 2 1s are 2, 2 1s are 2, 2 5s are 10, and 2 8s are 16. So 8, 5, 1, 1. Okay. So to find out this is the first one. Second one is molar mass of endoxyl, the second compound. 8 into 12, 7 into 1, 1 into 16, and 1 into 14. After addition, 133 grams and 8711. We cannot simplify it further. So this is the empirical formula. Okay, the ratio is same. Question number 13. Identify the substance that has formula mass of 133.5 am. Magnesium chloride, this is sulfur chloride, boron chloride, aluminium chloride. Find out the molar masses separately. And you will see that aluminum chloride is 133.5. So this is the correct option, D. 14. Calculate the number of atoms in each of the following sample. Now, in this case, we have to find out the number of atoms. Formula is same which you used in the previous case. Number of atoms is equal to number of moles multiplied Avogadro's number. Moles are 3.4. Avogadro number, I told you, learn it. Then after multiplication, 20.5 into 10 power 23 or shifting decimal 2.05 into 10 power 24 atoms. D part is a little bit different because moles are not given, mass is given. So you have to use two formulas. First formula for the number of moles, which is mass in grams over molar mass, and then you multiply that answer by Avogadro's number. Okay, or you can directly use this formula. Number of atoms is equal to number of moles, they are mass in gram over molar mass into Avogadro's number. Mass in gram is 23, molar mass of sodium is 23, and by multiplying it with Avogadro's number, you will get the answer 6.022 into 10 raised to power 23 atoms. In the same case, we will also use the formula that this previous one, because again mass is given and they ask about the number of atoms. So mass in grams is given is 1 gram. Mass in grams is only 5 grams. Molar mass of hydrogen is 1 gram, and Avogadro's number you have to learn. So 5 over 1 into Avogadro number give us the answer 30.1 into 10 power 23 or 3.01 into 10 power 24. Question number 15, calculate the mass of the following. In this case, you have another formula, very important question, very important formula. The formula is mass in gram. Mass in gram or formula we have done before, but that formula we will use in the case when number of moles are given. Okay, but in this case, number of moles are not given. In this case, the given value is of atoms, molecules are given. If atoms or molecules are given and ask about the number or ask about the mass, then you will use this formula. Okay, which formula? This mass in grams is equal to number of atoms or number of molecules into molar mass over Avogadro's number. Okay, so read the question carefully and see moles are given or atoms or molecules are given. If moles are given, then use mass is equal to number of moles into molar mass, that formula. But if number of atoms or molecules are given, then use this formula. Okay, atoms are given or molecules. You can see in this question, part A, we use atoms because atoms are given. And part B, you can see molecules are given. So in formula, instead of atom, we use number of molecules. The formula is same, but just instead of atom, you will use the molecules. Data given is number of atoms are given. That is of iron. We need molar mass of iron, so it is 56 gram. Mass of iron we have to find out. Avogadro's number we have to learn. The formula is mass in grams is equal to number of atoms into molar mass over Avogadro's number. So put the values, multiply and divide. The answer is 3.01 into 10 power minus 4 grams. Okay, this is the answer. B part, number of molecules are given, and again one very important thing which you have to keep it in the mind, that this is nitrogen gas. Nitrogen gas means N2. Mostly the student, they do this mistake that they multiply, they put the molar mass of nitrogen 14, but 14 is for one nitrogen atom, and you know that nitrogen gas means nitrogen exists in dimolecular form, in N2 form. So you have to multiply the molar mass of nitrogen by 2, which will give you the answer 28 grams. So number of molecules given are 2 into 10, 19, and molar mass in this case is now 28. Avogadro's number after solving you will get 9.3 into 10 minus 4 grams. C part, again molecules are given, and that is of water, and you have to put the values. Just molar mass of water you have to find out, 18 grams. By putting the values you will get the answer 2.99. You can do this division directly or indirectly by dividing the term and these power values just by taking the 23 up. Let's subtract minus 23, so we'll give 10 power 2. So you can do directly with calculator or you can do by this method. Both are correct. Okay, if the answers have little difference in points, so no problem. Part D, 3 into 10 power 6 atoms of aluminium. Molar mass of aluminium is 27. Mass of aluminium, mass of aluminium. Avogadro's number of nitrogen, okay, mass of aluminium is 27 gram. We have to find out the mass of aluminium. Avogadro's number, you know, this is mistakenly iron, but this is aluminium. Okay, mass in gram you have to find out. Put the values. The values are, I told you, this is 23. When 23 will go up, become minus 23. Answer is minus 17. And by shifting the decimal, you can get 10 power minus 16 grams. So this is the answer. This is aluminium, okay, not iron. Mistakenly, it is mentioned iron. Question number 16, identify the branch of chemistry. Although you have done it in the as assignment, but again I am repeating this question. Cornstalk grows from a seed, plants, living organisms, or biochemistry. Dynamite explodes to form mixture of gases. Dynamite contains inorganic compound, so inorganic chemistry. Purple iodine vapor appear when solid iodine is warm. We are doing practical. So analytical chemistry, gasoline fumes are ignited. Gasoline is an organic compound. Hydrocarbon, organic compound. Organic chemistry, silver article tarnishes in air. So you can see it in environmental chemistry because you can see it. Ice floats in water floating, physical phenomena, physical chemistry, acid rain, environmental problem, environmental chemistry, fluorinated hydrocarbons in drinking water are carcinogens, water pollution. So it is environmental chemistry. In Pakistan, most of the factories use wet process for cement. On large scale wet process, production of cement is large scale. So industrial chemistry, carbon-14 isotope of carbon and isotopes we study in nuclear chemistry. Think tank. Question number 1. What mass of sodium metal contain the same number of atoms as 12 gram of carbon? Avogadro number we know is 6.022 into 10 power 23. 1 mole of sodium atom is equal to 1 mole of carbon. So it have Avogadro number of particles. 1 mole sodium, 1 mole of carbon. And I told you 1 mole of other substances they always contains Avogadro's numbers of particles. So 23 grams sodium will contain the same atom as 12 gram of carbon. Okay, because I told you 1 mole of all the substances they always contain same number of particles. They may be atom molecules or all. Question number 2. What mass of oxygen contain the same number of molecules as 42 grams of nitrogen? So 1 mole of nitrogen, 3 moles of nitrogen, 1 mole contain 14 grams, so 3 moles they contain 3 into 14, 42 grams. Similarly, 1 mole of oxygen, atomic mass of oxygen is 16, but there are 3 oxygen, so 3 into 16 equal to 48 grams. Okay, so this is 42 grams, 3 moles of nitrogen, and this is 48 grams, 3 moles of oxygen. Calculate the mass of one hydrogen atom in grams. So mass of hydrogen formula, atomic mass of hydrogen over Avogadro's number. Mass of one hydrogen atom is equal to atomic mass of hydrogen over Avogadro's number. Use this formula. Mass of one hydrogen atom is equal to 1.008. Avogadro's number is 6.022 into 10 power 23. Answer is 0.1674 or 1.674 into 10 power minus 24 grams. So mass of one hydrogen atom, you can use this formula and you can get the answer or the values. Formula is same as we used in the previous case, that mass of hydrogen atom is equal to the formula was the number of atoms multiply molar mass or atomic mass. So atomic mass of hydrogen multiply by 1 because they ask for one hydrogen atom. So if we multiply this thing with 1, it will give us the same answer. So you can use the formula completely. Mass of atoms or mass is equal to a molar mass into number of atoms divided by Avogadro. The number of atom in this case is 1. Okay. Formula is same, don't get confused. And the mass of one hydrogen atom is 1.674 into 10 power minus 24 grams. Okay. Observe the figure, it shows particles in a sample of air. So nitrogen gas, N2, H2O, water, O2, CO2, argon, Ar, argon. These samples are present. So how many? Nitrogen, water, oxygen, carbon dioxide, and argon. Total 5 substances are there. How many substances? 5. Is air a mixture or pure substance? Explain. We have done it before that air is a mixture of these different gases because it contains nitrogen, oxygen, water vapors, carbon dioxide. So it is a mixture of different gases. It is not a pure substance. C part, identify the formula of each of the substance in air. Formulas are N2, H2O, O2, CO2, and argon is Ar. Because it is noble gas and it exists in atomic form, so we will just write Ar. Decide whether each substance in air is an element or a compound. So just see, nitrogen is made up of similar atoms, so it is element. Argon again element, monoatomic molecule. Oxygen element because made up of similar atoms, O2. Carbon dioxide is compound because it is made up of dissimilar atoms. And water is compound. So water and carbon dioxide, they are compound, and nitrogen, oxygen, argon, they are elements. What is the most common substance in air? Nitrogen is the gas which is present in highest percentage in air, and its percentage is 78%. 78% by volume. 78% means 78 out of 100 is nitrogen gas, and then the rest is the other gases. Calculate the number of hydrogen atoms present in 18 grams of water. We have to find out the number of atoms. So number of atoms, you know that 18 grams of water, 1 gram is or 1 mole water contain 18 gram. The mass of 1 mole of water is 18 gram, and 1 mole contain Avogadro's number of particles. Okay, 1 mole contain Avogadro's number of particles. So if we have 1 molecule of water, it has 2 hydrogen atoms because they asked about the hydrogen atoms are present. 1 mole contain 18 gram, it contains Avogadro number of particles. But how many hydrogen atoms are? So see the formula of water. 1 molecule of water has how many hydrogen atoms? 2 hydrogen. Okay, 1 water has 2 hydrogen atoms. Then Avogadro number of water molecules will have how many hydrogen atoms? So just you have to multiply 2 by Avogadro. 1 water has 2 hydrogen atoms. Avogadro number will have how many? 2 into Avogadro's numbers, 1.204 into 10 power 24 atoms. Last question is calculate the total number of atoms present in 18 grams of water. Total number of atoms present in 18 grams of water. It is conceptual, very important. Mass of water is 18 grams, and which is equal to 1 mole of water, and 1 mole of other substances. I told you they contain Avogadro's numbers of particles or atoms. So in this case, we will say 1 mole of water contain Avogadro number of molecules. So one molecule of water has how many hydrogen and oxygen? 1 mole of water has 2 hydrogens and 1 oxygen. So total number of molecules, or 1 molecule of water has total number of 2 hydrogen and 1 oxygen, 3 atoms. Okay. Then Avogadro number of water molecules, or total number of atoms in 18 grams of water will be 3 into Avogadro's number. So you will get the answer. So simple thing is first find out the number, the gram. If this gram is equal to 1 mole, so 1 molecule contain Avogadro's number of molecules, and 1 molecule of water has 3 atoms. So Avogadro number will have how much? So you have to multiply 3 by Avogadro's number, it will give you atoms. Okay, this is molecule, this is not atoms. 1 mole of water have Avogadro number of molecules. Clear? Then how many atoms are there? 1 molecule of water has 3 atoms. So Avogadro number of molecule will have the 1.806 into 10 raised to 24 atoms. Okay. So this was the last question. I'm sure you understand this lecture. Inshallah, chapter number 1 is finished. Alhamdulillah, and inshallah we will start chapter number 2 in next lecture. If you have any problem regarding chapter number 1, so you can ask me through WhatsApp. Okay. Thank you. Take care. Allah.